All right, let's talk about waste. We all know the story, right? It just piles up, takes up space, and pollutes everything. But what if that whole story is wrong? What if we've been looking at waste as an ending when really it's a beginning? Today, we're going to dive into a technology that doesn't just get rid of waste. It actually turns it into treasure.
So let's just ask the big question right up front. What if all that stuff we throw away, leftover crops from a farm, old tires, all that municipal waste, what if it wasn't a problem to be buried? What if it was the raw material for creating clean energy, for making our soil healthier, and for building stronger local economies?
The secret sauce here, the key to this whole transformation, is a process called pyrolysis. Now, this isn't just another fancy word for burning. We're talking about using intense heat to break down organic material. But, and this is the absolute most important part, it happens in a sealed environment with zero oxygen.
And that's a really critical distinction to make. Pyrolysis is not incineration. See, incineration uses oxygen to burn waste. And when you burn things, you get ash and a whole lot of emissions. But with pyrolysis, because there's no oxygen, nothing actually burns. Instead, the heat decomposes the material, it chemically breaks it down into its most basic components, creating totally new and really valuable resources.
So what do we actually get out of this process? Well, pyrolysis gives you three amazing, totally different products. You get a solid, which is called biochar. You get a gas, called syngas. And you get a liquid, which is known as bio-oil. So for the next few minutes, we're going to break these down one by one.
Okay, let's start with the solid. Biochar. The easiest way to think about it is like a kind of superpowered charcoal. It's this incredibly stable, carbon-rich stuff that has some just, mind-blowing applications.
Biochar is a total game changer, especially for farming. Its structure is super porous, so it acts like a sponge in the soil, helping it hold on to water and all the good nutrients. But maybe the biggest deal is its climate impact. When you put biochar in the ground, you are literally locking away carbon for hundreds, sometimes even thousands of years. And it's so versatile, you can even use it to filter pollutants out of water, or as a feed additive for livestock to help cut down their methane emissions. Just think about what that means in the real world. A farmer can use less chemical fertilizer, get bigger, healthier crops, and actively pull carbon out of the atmosphere. All of that from a single product that was made from stuff we used to call trash. It's a win-win-win.
All right, next up is the gas that's created in the process. It's called syngas, which is just short for synthetic gas.
And syngas is just an incredibly flexible fuel. You can use it right there on site to run a turbine and make your own electricity. Or you could pipe it over to a local factory to provide heat for their manufacturing. But it's more than just a fuel you can burn. It's also a really valuable chemical building block. It's the precursor for making things like advanced biofuels or even clean hydrogen. And this is where the idea gets really powerful. Picture a small rural community that has to rely on noisy, expensive, polluting diesel generators for power. With a system like this, they can take their own local waste, create syngas, and generate their own clean, reliable electricity. We're talking about true energy independence. And finally, that brings us to our third output, the liquid. This stuff is called bio-oil. It's a dense, dark, and really energy-rich liquid fuel. The best way to think of bio-oil is as a drop-in replacement for a lot of fossil fuels. It can be used as is in big industrial boilers or kilns instead of heavy fuel oil. But the potential here is huge. With a little bit more refining, you can upgrade this bio-oil into things like renewable diesel for trucks or even sustainable jet fuel. Plus, it can be the starting point for making bioplastics, resins, and all sorts of other high-value chemicals. So the application is super direct. A local factory could literally take its own wood waste, for example, create bio-oil from it, and then use that same oil to power its own machines. It's a perfect closed loop that slashes their carbon footprint and their fuel costs at the same time. So we've got these three amazing products, but how does this all actually happen, especially in some of the remote or smaller scale places we've been talking about? What's the engine that's actually driving all this? Well, the key is the technology. The source material for this explainer zeroes in on a specific solution called the UNI Box. And what it is basically a whole pyrolysis factory, miniaturized and packed neatly inside a standard shipping container. This design is pretty genius. Because it's in a shipping container, it's totally mobile. You can truck it almost anywhere, a farm, a factory, a small town. It's scalable, so it can be built to match the exact needs of that community. And get this, this is the real kicker. The whole system is so efficient it can actually power itself using a little bit of the syngas it produces.
That makes the entire operation energy self-sufficient.
So when you bring the solution right to the source of the waste, you get this amazing cascade of benefits. You're cutting greenhouse gas emissions, you're keeping waste out of landfills, you're generating renewable energy, and you're creating valuable products that make the local economy stronger. It's literally the circular economy in a box.
So, after looking at the process, the products, and the technology that makes it all happen, let's just boil it all down to the one big idea you should walk away with.
That's it. That is the fundamental shift in thinking. This kind of technology lets us stop looking at waste as a problem that needs to be buried and forgotten. We can start seeing it for what it truly is, a local, available, and valuable raw material that's just waiting to be unlocked.
And that really just leaves us with one final thought to chew on. If a process like pyrolysis can take almost any organic waste, from corn stalks to wood chips, even some plastics, and turn it into valuable resources, then what does the word waste even mean anymore? Maybe it's just a resource we haven't found the right key for yet.